Okay, next I'd like to introduce Angelo Armijo. He's with our Bridge Research Bureau, and he's going to present on 15 years of bridge research in New Mexico.
Good afternoon, everyone. My name is Angelo Armijo. I work with the Research Bureau for New Mexico Department of Transportation. Today I'll be presenting 15 years of New Mexico DOT bridge research. Over the past decade, the Research Bureau has supported, funded, managed innovative bridge research. These project findings and results have helped NMDOT to advance applications, manuals, and implementations on bridge design, construction, and maintenance. Through collaboration with both public and private entities, NMDOT bridge research has covered several key areas. All of these efforts are a culmination of dedication to applied transportation research. This presentation will highlight research projects relevant to bridge design, repair, maintenance, structural safety, cost savings, and lifespan increase. We'll cover projects from ultra-high performance concrete, load rating bridges, increased max truck weights, oversized and overweight vehicles, unknown bridge foundations, and then we got a couple of state innovation council projects, which is SmartPile and UAV for bridge inspection, as well as two pooled fund studies, Bridge Deck Preservation Portal and SBRITE. As you can see from this graphic, we still have 5 ongoing projects. 2 are pooled fund projects. 2 are part of the STIC, which is the State Transportation Innovation Council, and currently 1 research project, which is in its 5th phase, which is ultra-high performance concrete. So it was anticipated that successful implementation of UHPC in bridges throughout New Mexico would have significant positive effect on how bridges are designed, constructed, and maintained. So in 2009, the NMDOT Research Bureau awarded the research project to New Mexico State University to determine the UHPC's feasibility and limitations for pre-stressed concrete bridge applications. At this time, 50% of bridges in New Mexico used pre-stressed concrete, so incorporating UHPC in design, it would have the potential to impact the cost and performance of bridges. Some of the benefits, it can reduce the life cycle cost of bridge girders. It can double the service life when compared to high performance concrete. It can increase the lifespan and decrease maintenance. It can reduce or eliminate mild steel reinforcement. It can reduce girder lines and girder size. It can reduce quantities of materials as well. And just here we have a couple of the preliminary batches that were created in phase 1 of this project. So I'm going to go over each phase real quick. So in phase 1, case studies were conducted to investigate the advantages of implementing UHPC in bridge superstructure design. This led to phase 2, in which NMSU developed mixture proportions for UHPC using local materials. Phase 3, UHP was incorporated into pre-stressed concrete bridge girders in New Mexico, and a fundamental understanding of creep and shrinkage behavior of the UHPC mixture was assessed. During this phase, they constructed a bridge, which would be monitored into phase 4, and this was Bridge 9706. It was tested and monitored to investigate the performance of UHPC compared to HPC, high performance concrete. Currently, this project is in its 5th phase, and they're continuing to document, monitor, and assess field implementation of a UHPC overlay that they incorporated into a bridge in Socorro, New Mexico. And this was the first non-proprietary UHPC overlay constructed in the United States. So UHPC is an emerging material technology in which concrete develops very high compressive strengths and exhibits improved tensile strength and toughness. In phase 1, a comprehensive literature search and historical application review was completed to determine the characteristics and properties of UHPC currently being used in design applications. Trial designs and cost analysis on typical pre-stressed concrete bridges using UHPC were conducted. The use of UHPC was evaluated through a parametric study on 2 bridges here in New Mexico. The first was the I-25 and Doña Ana interchange in Las Cruces, and this bridge is a typical simple span bridge. The second bridge was in Sunland Park River Crossing in Sunland Park, New Mexico, and this bridge is the typical continuous span bridge. The goal of this parametric design study was to implement UHPC in an efficient and cost-effective manner. Results from this phase indicate that the initial high costs could be offset with careful material selection. Costs were evaluated based off local material prices, design parameters, and projected maintenance schedule. So this led to phase 2. The findings from phase 1 determined that a more economically and readily available UHPC mixture would need to be required for successful implementation into bridges in New Mexico. So in this phase, mixture proportions of UHPC with local materials were developed and optimized. Curing practices were also optimized in this phase, and the optimized mixture was resistant to cracking and freezing and thawing cycles. The results demonstrate that UHPC has excellent durability properties. So in this picture is a specimen from the freezing and thawing cycle that held up really well, and also the freezing and thawing chamber. So the materials that were selected were a Class F fly ash, local sand, cement, and silica fume. In phase 3 of the study, UHPC investigated the creep and shrinkage of UHPC materials, which were expected to be significantly different from normal and high-strength concrete. Modifications of mixing, curing, and testing specifications were recommended to ensure the quality, strength, and durability of UHPC mixtures. Additionally, the design behavior of UHPC girders was investigated through large-scale flexural tests. So this bottom left image is a digital image correlation test that was conducted in the lab on a UHPC girder. And the one to its right is HPC. The red area depicts high tensile strain, with the blue indicating compressive strain. So we can see here that the ultra-high performance concrete is a little better. During this phase, field instrumentations were initiated on a bridge 9706 to monitor both short and long-term performance. I want you to note here the design you can see on the right is UHPC. It's a little bit smaller when compared to the HPC. Also in the lab, they did full-scale testing on bridge girders. This top one is the longitudinal 4-point bending, and this next picture is transverse 3-point bending. Bridge 9706 was recently constructed in the previous phase and incorporated the use of UHPC. In this phase of the research, this bridge was load tested and monitored to investigate the performance of UHPC under loads. Mixture proportions were further optimized during this phase, and also additional uses of UHPC were investigated. Some of these other uses could be precast in place field joints, precast applications, substructures, and bridge deck overlays. This bridge is located in Anthony, New Mexico. So you can see here they put trucks on there and they were load testing it. And currently this project is in its 5th phase and it's still ongoing. The first objective was to identify a locally produced UHPC mixture with adequate workability and strength for use as a protective overlay over concrete bridge decks. They chose bridge number 7032, and that's in Socorro, and it was fitted with the UHPC overlay and will continue to be monitored. The test results would establish an experimental background and would be used to verify analytical procedures and develop design tools and recommendations for implementation of this material. So we know some of the benefits of UHPC. It has increased strength and ductile behavior and allow the concrete to deform, support flexural and tensile forces even after initial cracking. UHPC demonstrates a high resistance to abrasion and is much better than that of normal strength concrete. UHPC exhibits almost no shrinkage or creep, which makes it the material very suitable for applications in pre-stressed concrete. The material could replicate the macro and micro texture of the formwork, resulting in high-quality textured or smooth surfaces. UHP properties enable designers to construct bridges with longer spans, improved durability, and smaller structural members. And these pictures are the overlay for the bridge in Socorro, and it's continued to be monitored. We're going to move on to the next project. This one was called Characterization of Unknown Bridge Foundations. It is evident that unknown percentage of bridges in New Mexico, they had missing foundation data, which could also be high, and they were highly vulnerable to scouring that is induced by water flow coupled with erodible soils. Conventional excavation, coring, and boring excavations to determine unknown bridge foundation depths and types are deemed to be too expensive and destructive. Therefore, a real need to research and develop lower-cost, non-destructive testing methods to provide foundational depth and type data on unknown bridge foundations were needed to aid in evaluating scour safety. The goal of this research was to determine the characteristics of unknown bridge foundations, such as type, depth, geometry, and materials. Field tests off local practice were first conducted on New Mexico bridges to determine the depth of the foundations. Test procedures of non-destructive testing methods were developed and helped NMDOT engineers to characterize unknown bridge foundations. The study showed that the reliability of locating depth of the pile decreased as the distance between the borehole and the pile increased. The test methods that were created, they were both done in the laboratory and on the fields. NMDOT engineers can follow these procedures and perform non-destructive tests to characterize unknown bridge foundations. So this bridge here is located in the Gila. You can see towards the bottom the waters created some scouring. This one as well, so we can see the need for how safety is definitely needs to know for bridge foundations. And the last one, I mean, they looked at wooden structures as well. And this is bridge number 1190, and it's located in Springer. So the next project we'll go over is load rating bridges with no as-built plans or non-engineered bridges. Bridge loading is the process of determining the safe load carrying capacity of a bridge using analytical and experimental methods, as well as a combination of the two. 300 bridges in New Mexico in the state bridge inventory did not have as-built plans or considered non-engineered. Researchers from NMSU and NMDOT coordinated to compile relevant data to perform load rating analysis on selected group of bridges to develop methods to determine bridge load ratings and posting loads for these concrete bridges. This project was actually used to aid phase 4 of the UHPC project as they did the load tests on Bridge 9706. This study provided valuable information of future evaluations of pre-stressed concrete bridges without plans. And the importance of it is it ensures a safe and efficient infrastructure that maximizes public safety and the efficient movement of goods and services within the state. And as you can see here, there's a couple load testings that they've done on several different bridges. So we know that bridges have load carrying capacities, but we need to recognize that the trucking industry are allowing for heavier weight vehicles with higher load carrying capacities, which cause stress on our bridges. The Western Transportation Institute was contracted by the Research Bureau to document current knowledge and practice related to multiple dimensions of weight limits for specialized hauling vehicles, with a focus on scenarios of interest to NMDOT. The trucking industry has developed short wheelbase trucks with capacities of 80,000 pounds, which contain 4 to 7 axles, and those are referred to as specialized hauling vehicles. Specialized hauling vehicles can cause load effects in some bridges that exceed the analytical vehicles used to design and assess the bridges. Certain types of SHVs may pose a greater risk than others, which induce the need for bridge weight limit posting. The impact of SHVs to bridge damage is mostly attributed to short-span bridges from 25 to 55 feet. Bridge weight limit posting is expected to increase with the allowance of SHVs, especially for short-span timber and steel bridges. The loss of a bridge and the access it provides can negatively affect the local economy. So this is just a couple pictures of some specialized hauling vehicles, as well as some that are loaded to capacity. And as Shane showed with the fracking trucks, some that are much more capable of carrying excess loads. This graphic shows the critical bridge zones in New Mexico based on bridge deck conditions. And you can notice that as we head further north into higher elevations, New Mexico has more bridges that are susceptible to loads such as these from the specialized hauling vehicles. Assessment of New Mexico fee structure for oversized and overweight vehicles. So we know the higher stress imposed on the bridge by oversized and overweight vehicles has the potential to reduce the service life of the bridge and could also lead to fatigue failure. This research project focused on a comparative assessment of oversized and overweight vehicle permit fees in New Mexico and neighboring states. Bridge deterioration is a big concern as oversized and overweight vehicles have larger load carrying capacities. Loads that exceed a bridge's design load can both compromise the safety and accelerate deterioration of the bridge structure. Therefore, in this, they created a simplified data-driven model to predict the condition ratings of bridges. This algorithm shows promise for life cycle analysis to estimate the cost of damage to bridges and assist with risk-based scheduling of bridge inspection intervals. The project concluded that New Mexico charged some of the lowest flat permit fees, and it was unlikely that the state was recovering sufficient funds to maintain the state network of bridges when compared to surrounding states. The Research Bureau also participates in State Transportation Innovation Council, which we get federal highway money to assist with other projects. So recently they awarded Smart Pile technology. Smart Pile can automatically record delivered blows from the hammer to the pile. It can record the elevation of the pile. It can calculate the average stroke, energy, and bearing capacity of the pile being driven. It can reduce the number of personnel participating in the testing operations. NMDOT plans to use Smart Pile Inspector to replace bridge number 6840, which is a single-span bridge with driven pipe piles as the supporting foundation. So another project that we just begun is going to be unmanned aerial vehicles for bridge inspection. This has several advantages in its preliminary state, and I know that there was someone else out here that uses drone as well. So using these drones, it can create safety for personnel in unsafe areas, such as the Gorge Bridge. That's a hard one to inspect. Drones could potentially save costs. It could minimize the impact to traveling public, as you wouldn't have to shut down a lane for a truck. And it could save time. Most of the time, bridge inspections with the drone in preliminary stages, it can be done rather quickly. Due to the challenge of aging infrastructure systems in the U.S., a demand for more frequent inspections exists, and that's why we invested in this project. So as we can see here, this is the Gorge Bridge in a traditional style. They were using ropes and with a man hanging there. So drones, have ease of access to flight. They can detect things. We can equip them with LiDAR, radar, and thermal cameras. The Research Bureau also participates in pooled fund studies in which other DOTs will run the research, and we pool our money, and we all benefit from sharing the findings of that. So we're invested in 2 currently, and that's the Bridge Deck Preservation Portal and S-Bright Engineering Center. For the Bridge Deck Preservation Portal, the objective is to improve the quality of inspection data for the purpose of improving safety of steel bridges. The Iowa DOT led an initiative to develop a framework for Bridge Deck Preservation Portal intended to be widely available to engineers across the nation and widely acceptable and tailorable to bridge-specific scenarios. S-Bright. The objective is to develop the Steel Bridge Research, Inspection, Training, and Education Engineering Center, focused on existing steel highway bridges. These are still currently going on, and we do not have final reports for these. I want to share another picture that Shane has previously shown. This is the bridge on I-40 near Rio Puerco, and I think it's just great that they left this up and did not take it down. And I believe this one was constructed by a Kansas company as well. But potential uses from the findings of these studies could help monitoring these steel bridges. The research conducted will prove to be vital for creating procedures in design, maintenance, and construction for bridges. The findings can be shared with other agencies in the effort to expand knowledge and solve transportation challenges. The Research Bureau continues to implement research in bridge components with the end goal of extending service life, reducing maintenance costs, and improving our transportation infrastructure. The Research Bureau continues to research bridge components. And I'm just going to show a great picture here of the Gorge Bridge as well. I just want to give thanks to NMSU, UNM, Montana State, and FHWA. I noticed we got a few Aggies here. I myself graduated from UNM, so we appreciate all the research and participation. This graphic here is just going to give you a little insight as to what the Research Bureau can do. And just wanted everyone to know that you can find all these final reports for all these projects on the Research Bureau website. And they're definitely more complicated and much longer than I could go over here in just the brief time I had. So thank you, everyone, for being here, and I appreciate it.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.